We've skipped chapter 2 just for a moment. We'll come back and cover some topics about matrices, but we're moving on to chapter 3, nature of graphs. The very first section we're going to cover is symmetry and coordinate graphs. Much of this you can do on your own, so we will cover 3.1 more in depth in class, but I want you to have this background prior to arriving to class next time. So follow along with me as we talk about types of symmetry. Part of the graph below is missing. The rest of the graph can be found by reflecting the current graph over the x-axis. Draw the rest of the graph. You see what's going on. So you've got this figure, and you're going to reflect it about, as it says, the x-axis. So go ahead and do that, and we can go through the prompts together. I'd like for you to kind of go through the prompts on your own, and then let's see if we don't come up with the same conclusion. So pause the video and follow through the prompts, and then I'll catch up with you. And so your graph should look like mine. When reflected about the x-axis, you ought to see that the y-intercept of the image is -2, whereas the as the y-intercept of the original, which is called the pre-image, is at +2. Let's go to the prompt. So we're asked over here, what point corresponds to the point -3, 5? Well, -3, 5, you can see is, let me make this kind of cute. -3, 5 is right there. And its image point, so again, the original point is the pre-image, and the final point is the image point. So we want to write the ordered pair for the image point. And that point, of course, is at -3, -5. So notice how when we reflected about the x-axis, where are you, pen? When we reflected about the x-axis, notice how the x values remain the same. Those y values, however, those are different. So how do the x values compare? Well, they remain the same. The y values, well, those are the opposite of each other. That's always going to happen as we talk about reflection with respect to the x-axis. Here's something else we notice about reflecting something about the x-axis. This is a little bit further down. It says the graphs that are reflection symmetric with respect to the x-axis are not functions. Why not? Well, they fail the vertical line test, and so I would write that in the space provided. In geometry, you would do several trials, and then you would come up with a conjecture, which is an educated guess, and I'm trusting that you can kind of see where this is going. If not, we'll get through it together. So, in general, if we're reflecting something about the x-axis, it's the x value that stays the same, and the y value is what becomes the opposite. So you're given 3 points, and you're asked if they're reflected about the x-axis, what's the image point? Again, the image is the after point. The pre-image is the before, the image is the after. And so I'll do one of these with you, and I'm going to trust that if we do one together, you can do the other ones on your own. So if you're reflecting about the x-axis, the x-coordinate stays the same, and as we stated above, it's the y value that we have to take the opposite of. So follow that as you do those next two ordered pairs, and meet me on the next page when you're finished. So here we're going to now reflect about the y-axis. So once again, I'm asking you to follow along with me. It says part of the graph below is missing. Come on, highlighter. Part of the graph below is missing. The rest of the graph can be found by reflecting the current graph over the y-axis. Draw the rest of the graph. So again, pause and let's see if we don't end up with the same thing. This is what I got when I reflected about the y-axis, and yours should match up as well. Is it a function? Yes, it's a function. It passes the vertical line test. The next one asks again, what point corresponds to -3, 5? Remember that that point -3, 5, because it's on the original graph, that's the pre-image. Its image point is right there. And so you're asked to write the coordinate of that point and then answer those two prompts. How do the x and y values compare? Well, so we can clearly see that the image is at +3, +5. So when we reflect about the y-axis, notice how this time it's the y value that stays the same and the x values are now opposite each other. So how do the x values compare? Well, we're working with opposites again. And the y values, those have remained the same. Okay, so let's scroll on down and follow along with me as we do so. So these are called even functions. So even functions are reflections about the y-axis. Anytime you have a reflection about the y-axis, you have an even function. So once again, we're going to write this rule using ordered pairs. So when we're reflected about the y-axis, it's the y values that stay the same, and we take the opposite of the x value. That being said, we can now do another 3 ordered pairs where we reflect each of them about the y-axis. The y value stays the same, and you take the opposite of the x value. Okay, so go ahead and finish those up and then meet me on the next page. And the last task is to reflect about the origin. Now what this involves is that we do a combination of an x-axis and a y-axis reflection. So at the top it says part of the graph is missing. The rest of the graph can be found by rotating the current graph around the origin. So you can literally rotate around the origin, and that's a concept you did in geometry. We're going to kind of look at that rotation differently. We're going to reflect, come on highlighter, we're going to reflect the original graph about the x-axis and then the y-axis, or vice versa. So go ahead and pause and then see if we don't agree with what the final graph looks like. So I chose this order. I took the original graph and I first reflected it about the y-axis, and then I took that image and reflected it about the x-axis. So what you see in red is the final image, and this is said to be a reflection about the origin. So once again, they're asking us to focus on this point up here of -3, 5, and to write what its image is. And so we can see that the image of that, so with -3, 5, is now at 3, -5. We're going to do the same kind of comparison as we've done before. The x values are the opposite. The y values are also opposite each other. So when you reflect about the origin, your x values and your y values both become the opposite of their pre-image point. So one other thing that's worth noting is that anytime you have a rotation that's with respect to the origin, those are odd. So even functions are those functions that are reflected about the y-axis. Odd functions are reflected about the origin. If it's reflected about the x-axis, it's not even a function. Okay, so here we go again. If we have some point x, y, and it's reflected about the origin, then we just discovered that its image point, or all image points, are going to have the ordered pair opposite of x, opposite of y. So here we go, 3 points, all being reflected about the origin, and we know that we've got to take the opposite of both x and y values. So the opposite of x, the opposite of y. And we know that 0 has no opposite, so that's something I'm hoping that you have already familiarized yourself with and figured out on the previous slide. So in summary, now this isn't on your page, on your practice page, but if we have something like sorry, I paused and didn't feel like editing because it's a long process. In summary, if you are reflecting about the x-axis, if you're reflecting an object, if reflecting a graph, reflecting a coordinate about the x-axis, let me get this going, sorry, I'm wobbly here. If you're reflecting about the x-axis, we said that that's not a function. If you reflect something about the y-axis, then not only is it a function, but those are referred to as even functions. And if you're reflecting about the origin, then those are considered to be odd functions. Now in class we're going to develop this concept a little more, but here's what I want you to practice. I want you to practice just simply plugging in the opposite of x into various functions. This actually ties in really nicely with what we just did, and I'll make that connection in class, but here's some examples. So suppose I have the function f of x equals x squared. So what I'm going to ask you to do is find f of negative x. Well, if I plug in negative x, or I should really say the opposite of x, if I plug that in to the original function, well, any negative number or positive number squared is going to end up being positive. So given f of x, I want you to find f of negative x, which in this case is x squared. Okay? Maybe what makes this a little easier is to think of f of x as working with positive values of x, and what happens if we plug in negative values for x, what happens to the signs. Okay? This doesn't mean that you're always going to have negative values. It really means you're plugging in the opposite of the original. But just to understand this better, let's think of, we start off with positive x values, and we want to replace all of those positive x values with negative x values. Okay? And if that language isn't super clear, it's okay. It'll start to clear up in just a minute. So let's suppose we have some function f of x equals x cubed plus x, and I want you to find f of negative x. So we know that if you take any negative number and multiply by itself 3 times, you're still going to end up with a negative number. And if you replace positive x over here with the opposite of x, well, you're going to have the opposite of what you started with. So in this case, we can say f of negative x becomes negative x cubed minus x, just because those signs are going to change. Let's look at another one. Hopefully it's becoming a little clearer, but we'll do a few more examples and make sure you've totally got it. So let's suppose we have f of x equals, x cubed minus x plus 1. And once again, we want to find f of negative x. I'm going to do an extend page. So f of negative x. So whenever I see x in the original function, I'm going to replace it with negative x. And so notice how I'm just making those substitutions. The result is, well, if I take a negative number times itself 3 times, I still end up with the negative number. Our final answer we want to write without the parentheses. If I subtract from it a negative number, well, that becomes positive x and then plus 1. So that's all I want you to do for this. And so go ahead and do that very last page. And then when you get to class, you'll have a do now over this, and then we'll tie this together with some other things. All right? Don't come to class not prepared. Over and out.